Our next example, we have negative 5a to the fourth b times 2b squared minus 3b plus 19. We have a monomial times a trinomial. So because we have a monomial, meaning one term, the negative 5a to the fourth b, times the trinomial, we're going to distribute. And I'll talk about it in a few minutes when we use the FOIL method. But we're going to distribute the negative 5a to every term inside the parenthesis. So here we have negative 5a to the fourth b times 2b squared. That gives us negative 10a to the fourth b cubed. Then we take the negative 5a to the fourth b times it to the negative 3b. Please look at the signs in front of each term. There's a minus sign in front of the 3b, so we want to carry that as we multiply that negative 3b to the negative 5a to the fourth b. And this gives us 15a to the fourth b squared. And then lastly, multiply negative 5a to the fourth b to 19. And then we have here negative 95a to the fourth b. Let's put our parts together. We have negative 10a to the fourth b cubed plus 15a to the fourth b squared minus 95a to the fourth b. And then we look to see if the terms are like. And remember from the previous example, for terms to be like, the variable with its corresponding exponent must match exactly. And you notice here that the base b, the b's here, the exponents are not the same. Therefore, we cannot add these terms together, and we will leave our answer as is. Next example, number 4. We have negative 2x plus 7 times x cubed minus x plus 5. We are going to multiply by using the distributive property. We have a binomial times a trinomial. We are not using the FOIL method just yet. In order for us to use the FOIL method, we have to have a binomial in each parenthesis. And because the second parenthesis is a trinomial, we cannot use the FOIL method. So let's distribute. So we're going to take each term in the binomial, the negative 2x and the 7, and we're going to distribute that to every term in the trinomial. So let's take the negative 2x and let's distribute 3 times. We have negative 2x times x cubed, which gives us negative 2x to the fourth. We have negative 2x times negative x, and we know that two negatives will give us a positive, so that will be positive 2x squared. And then negative 2x times the 5, that gives us negative 10x. So we are finished at this moment with distributing the negative 2x. Now let's take the 7 and we're going to distribute the 7 3 times. So we have 7 times x cubed, that's 7x cubed. We're going to take the 7, multiply it to the negative x, that's negative 7x. And then we're going to take the 7 and multiply it to the 5. We have 35, positive 35. Now let's bring our terms together. We have negative 2x to the fourth plus 2x squared minus 10x plus 7x cubed minus 7x plus 35. And as we bring our terms together, look to see in this expression to see if we have any terms that are like terms. And we do have a set of terms that are like, and that is the negative 10x and the minus 7x. So then what we're going to do is simplify. You're going to tell me what is negative 10x and minus 7x. So we have our answer as negative 2x to the fourth plus 2x squared. Tell me what is the negative 10x and negative 7x. That will be negative 17x, then plus 7x cubed plus 35. Now, if you notice that we have our x terms, but the variables are not the same. And a lot of times in math, whenever we have more than one term, we have a constant variable, which is x. We want to try to put our exponents in descending order this term. And when we talk about descending order, we're talking about descending order of power. So whenever you're saying descending order, we're looking at the expression or the term that has the highest degree, which is this negative 2x to the fourth, and then we go downward, descending, 4, 3, 2, 1. So in descending order, our answer would be negative 2x to the fourth plus 7x cubed plus 2x squared minus 17x plus 35.